Good afternoon, ladies and gentlemen. At the beginning of my talk, entitled Nanoscale Effects in the Welded Joints of Plastics, I would like to mention that I will speak about not gluing, that corresponds mainly for thermoset polymers like polyurethanes, epoxy resins, but about the welding, that is for thermoplastic polymers. These two ways of joining have important differences in processing and chemical structure of joints. So as I said, for welding we need to have thermoplastic polymers. They must have the weldability, and we have to choose the appropriate welding technique. There are numerous thermoplastic polymers with different weldability to each other. For our studies, we have chosen polyethylene, which is one of the mostly easiest for understanding and with an excellent weldability. Also, we have used one of the mostly conventional welding technique, namely welding with a heated tool, which industrial apparatus, you may see on the picture. And schematically, the welding process can be described as follows. So you have two polymer surfaces. You put the heated tool between them. You heat them above the melting point of polymers. You take off the heated tool and press both surfaces and get the welded joint as it is shown here. The mechanical investigations showed us the well-known effect of increased strength of the welded joint compared to the main material. Someone can say that it is because of the thickness of the welded joint. So we cut the rag, but still the mechanical investigation showed us the same result. So we asked ourselves why it is like that, why it happens, and what is in general the methods of mechanism of welding. Earlier we have reported about the nanostructurization and thermal properties of polyethylene welds. Here you can see the welding process in infrared spectra and the modeling of experiment. We have found that the welded joint really has the increased strength, the increased thermal stability, the increased thermomechanical properties, and even the increased melting temperature of the crystalline phase of polymer. That can be explained by orientation of polymer during the welding process and formation of more ideal crystals in the welded joint. That was confirmed by X-ray scattering. So to understand that, this effect, we turn back to the theories of welding mechanism. There are three main theories: rheological theory, diffusion theory, and rheological diffusion theory for mostly tricky researchers. In short, rheological theory says that welding occurs due to flow of polymer melt and specific rheological behavior of plastics. You may see the welded joint on the picture, and also the welded joint of multilayer sample. At the same time, this theory can't explain the weldingless of non-weldable plastics. Researchers in the field know that it is impossible to weld polyethylene with polypropylene, but that can be explained by rheological theory. The next theory is diffusion theory that says that welding occurs due to interdiffusion of macromolecules. You may see some diffusion here. But at the same time, what is diffusion in our case? Everyone knows what is diffusion in general. As an example, you put the drop of liquid in another liquid and you get diffusion. But in our case, let's imagine some hypothetical ideal conditions. Let's imagine that we have two liquids with equal viscosity, with equal molecular weight, equal liquids. And also we put them in the tube and we put equal pressure to each from both sides. Also, the surface between two liquids is ideal also. There is no defect and so on. So we will have the diffusion in this case. For sure, for polymers with high viscosity melt and with high molecular macromolecules, we won't get the diffusion. And the last rheological diffusion is rheological diffusion theory that says that the welding occurs due to both specific rheological behavior and diffusion of macromolecules of plastics. At the same time, we can ask ourselves, is welding possible without heating, but covering all the necessary conditions of both rheological and diffusion theory? So let's imagine the situation where we take two polymers and we press them with extra high pressure, covering all the necessary conditions. So in this case we will have flow and probably we would have some diffusion. But if we will get the joint, for sure not. The next further work we made is investigation of relaxation of the welded joints in time, and we found the relaxation of amorphous phase that is rather standard for polymers, but also we found the unexpected results, mainly the relaxation of crystalline phase with forming of another form of crystallines and also with some other heterogeneity in the welded joint. Also, we found the decrease of thermal stability and thermomechanical properties, even with decrease of melting point of crystalline phase of polymer. So now we are on the stage of modeling and development of new theories that can explain this situation, these results, and so on. At the end of my talk, I would like to thank to the staff of the Plastic Welding Department of Photon Electric Welding Institute, and especially to Dr. Valery Demchenko, who is my co-author and colleague in the field of these investigations. And thank you for your kind attention. Sorry?
Can you weld polymer composite materials?
Of course, we can, but we started to investigate the mechanism from the simplest polyethylene to understand what it is, and then to transfer this theory to more difficult from a chemical view polymers, plastics, composites, and so on. Thank you so much.